Firstly, I want to say how delighted I was to read this book and to engage with its chapters. And congratulations to this team. It's quite a feat to put together 13 chapters that cohere so nicely around the theme of future-proofing STEAM education. And I counted that there are 30 authors, most of whom are from UWC, so it really was an amazing collective achievement. As a physics educator and someone who believes passionately in the importance of breadth in science education, both at school and university level, I've been following the emergence of this concept of STEAM with some interest over the years. With the A for arts embedded into STEM to create STEAM, the aim was to enrich science education by drawing on the perspectives and the pedagogies of arts and humanities. And importantly, STEAM also rose as a critique of the concept of STEM itself. STEM is an acronym we use so commonly these days, and yet it's interesting to reflect that it's actually fairly new. It only really arose in around the year 2000. And before then we talk about science education or maths education. So STEM arises in around 2000, interesting as an economic term to signal disciplines that were perceived as useful for economic growth, and particularly in the US context, disciplines that were perceived to be important to meet labour market needs in the high-tech and defence industries. And so STEM as an economic term, in a way, sidelined disciplines that were perceived to be less important for economic growth. And by foregrounding the economic imperatives of STEM, in a way it didn't adequately emphasize the equally important role of STEM to develop critical citizens. And so right from the outset, there was this critique around STEM, that it created this artificial divide between the arts and the sciences. Whereas in fact good science has always been creative, it's always been interdisciplinary in nature. We think, for example, of Einstein, who was both an excellent scientist but also involved in wider issues of the day. And we think about other polymaths, for example, Newton and Da Vinci. This arts and science integration is important. More recently, we think about Steve Jobs and the integration of science with design and technology. And if we look at current Nobel Prize winners, it's also very interesting to see that they are 10 times more likely to be artists, painters, poets, musicians than their science colleagues. And so therefore STEAM arose as a way to counter this division between arts and sciences, but also as a way to address some of the challenges in STEM education itself. And chapter 11 in this book provides an excellent overview of some of these challenges. The first of these is that STEM is perceived by many learners globally as boring or difficult or not really relevant to their own lives. And this is often due to unimaginative teaching approaches. Unlike art subjects at school, which tend to be more discursive in nature, science teaching often tends to be very much in a transmission mode. And here in South Africa, we see the effect of this at the end of grade 9, when learners choose their matric subjects. Not nearly enough learners choose to continue with science to matric. And so it's so important that we have engaging and inspiring science teachers at the younger grades so that learners are inspired to continue in science. Another challenge facing STEM globally is the lack of representation of female students and minority students, which often again is linked to uninspiring teaching. Here in South Africa, the stats on enrollment in science and engineering degrees at universities show that these are still very racially skewed. Another criticism of STEM education is the lack of engagement with wider societal issues. Science is portrayed as value neutral rather than as a human endeavor rooted in cultural and social contexts, which of course makes science more interesting and engaging. Traditional science teaching also reflects very narrow views on ways of knowing about the world and doesn't adequately engage with indigenous knowledge systems. And so, given all these challenges in science education, this book provides us with excellent examples of how STEAM education can address some of these challenges. The first challenge is addressing the limitations of traditional science teaching. Several of the chapters address innovative teaching practices that foster student engagement and self-directed learning. There are teaching approaches here that foreground the processes of scientific inquiry and knowledge creation rather than just the products of these processes, the dry scientific knowledge in the science textbooks at school. The chapters tackle problem-based learning, inquiry-based learning, cooperative learning, the use of puppetry in classrooms, all in ways that enrich science learning. There's a chapter that explores cognitive conflict in fostering conceptual change in learners. And the chapters span all levels. There's a fascinating chapter on developing computational thinking right at the foundation phase, all the way through to the TVET level, where there's talk about more innovative teaching practices needed at that level. Chapter 8 looks at how problem-based learning, critical thinking and mathematical thinking come together in innovative maths teaching practices. And the important point here is not just to develop better maths thinkers in the academic setting, but to develop learners to be critical and creative thinkers in their own lives and to engage with global challenges. Extending the critique of traditional science teaching, Chapter 2 explores the inclusion of Indigenous knowledge into the science curriculum, and in doing so making science more engaging to culturally diverse learners. This chapter also speaks to broader conversations on the decolonization of the science curriculum. And then there are chapters that deal more closely with student diversity and inclusion. Chapter 9 explores inclusion and exclusion in science classrooms and the importance of giving voice to marginalized learners. And another chapter explores the role of language and literacy in science education, particularly for students who are not learning English in their mother tongue. And here the approach of pedagogical translanguaging is introduced, drawing on students' own multicultural and multilingual resources in the classroom. And then there's several chapters that address the wider context of science teaching. What is it like to be a teacher teaching in a South African science classroom? Chapter 10 focuses on the mental wellness of teachers, given the sorts of daily challenges that they face: lack of resources, overcrowded classrooms, and heavy workloads, and so on. In these circumstances, implementing innovation is not easy. This is compounded by a bureaucratic education system that emphasizes a lot of administration and excessive assessment and leaves little space for creativity or innovation. Teachers feel pressured to cover the curriculum, and even if they are exposed to innovative teaching approaches through teacher development programs, they often revert to their traditional approaches once they return to the classroom. And if this all seems rather bleak, Chapter 3 offers an exciting and promising way to address this problem with the concept of change laboratories. These change laboratories would bring together different stakeholders, in this case schools, universities, the Western Cape Education Department as a government education department, bring together these different stakeholders to rethink teacher professional development in a holistic way and to consider systemic changes that would tackle the burden of bureaucracy and foster teacher agency. I found this chapter very inspiring. There are also interesting chapters that deal with technology, robotics, as well as the development of entrepreneurial thinking. And Melanie will touch more on those. So in conclusion, congratulations to the editors and the whole team. This book is very timely. The concept of STEAM education has been around for the last 20 years, but very little has been done in South Africa in this area. And so this book really makes a very valuable contribution to the field.